So we're looking at our topology with switch 1, switch 2, switch 3, and switch 4. This once I'm going to first log into switch 2, maximize this, and execute the command show spanning tree. And the VLAN we have, let me as a reminder, show VLAN brief. Remember we created VLAN 150 yesterday with name CCNA. So we're going to check spanning tree for VLAN 150. So show spanning tree VLAN 150. So here is your command output, and I will go over it with you guys. As you see, the priority does not say 32768. It says 32918. Why? Because as I showed you, the priority field has been split in two. You have priority plus VLAN ID. So the priority is 32768. You add 150 to it. So 32768 plus 150 is 32918. The top portion of this command, or the top stanza of this command, is all information pertaining to the root bridge. So the priority of the root bridge is 32918. The MAC address of the root bridge is this guy here, the number highlighted, 000164AA DOC9. The cost, the root path cost to get to the root is 38. So we, at this point, should be able to garner that the root is 2 switches away. Because the cost for fast Ethernet, all these links that we are running here are fast Ethernet links. The cost for these links is 19. So when the cost is 38, you know that the BPDU traversed 2 ports, entered 2 switches. So the cost has been incremented locally from 19 to 38. The hello time, or the time between BPDUs, is 2 seconds. The forward delay, as I said, the time spent in listening and learning is 15 seconds. So it's 15 seconds for listening and then 15 seconds for learning. The max age time, I would not worry about this at your level. The max age is basically the number of seconds a switch will hold on to a BPDU received on a port before the BPDU is discarded. I said that once, but you don't really need to know what max age is at your level. The bottom stanza of this command gives you information about the local switch, about switch 2. So switch 2's priority is also 32918. So why did this guy, whoever this guy is, become the root? Because its MAC address was lower than switch 2's MAC address. So even if the first 3 characters you see, this guy, the root bridge, is 000, and switch 2 is 00D. So D is higher in hex than 0. Again, the hello time is set to, or the time between BPDUs is set to 2 seconds, and the forward delay is again 15 seconds. It's usually not recommended to mess with these timers. Now, port 1 is alternate, and remember, alternate ports are put in blocking, and the cost of that port is 19 because it is a fast Ethernet link. Port 2 is also an alternate path to the root bridge. It's a non-root, non-designated port, hence it was put in for blocking. Don't worry about this number. This is the priority field for the port itself. This is the port priority. This does not come into play till you get to your CCNPs. Port 3, as you see, is your root port, and it is put in forwarding. So 1 root port per non-root switch. Port 4 is also alternate and blocking. So this is switch 2. Let's go look at switch 1. So switch 1 should be 1 switch away from the root bridge, since switch 2 was two switches away. And we have a total of 4 switches. So when I say show spanning tree VLAN 150, the cost to the root bridge should say 19. Let's see. And there it is. The cost to the root bridge is 19, and the priority is 32918, same as you saw on switch 2. The top stanza, again, is information about the root, and the bottom stanza is information about switch 1, the local switch. Port 3 on switch 1 is the root port, and I will inform you that port 3 is connected to switch 3. So switch 3 should be our root. Port 1 is the designated port, which is connected to switch 1. So pulling up the topology, port 1 here is connected to switch 2. So of course this is the designated port, or the downstream facing port. And I believe port 3 is your root port, and this is port 3 up here where my arrow is, see, which is connected to switch 3. So let's go to switch 3 and check to see if that is the root. Show span VLAN 150. And switch 3 says that this bridge is the root. This is information switch 3 is providing about the root bridge, and this is information switch 3 is providing about itself. However, you see the MAC address of the root bridge and the MAC address of itself is the same, which means switch 3 is the root bridge. Also, as I said, all the ports on the root bridge will be designated ports, and you see that that seems to be the case. All the ports on this switch are designated and forwarding. Now, what if I wanted to make switch 1 the root bridge? Can I change switch 1's? So I'm back in switch 1. Can I change switch 1's MAC address? No. MAC addresses are hard-coded. Can I change its priority? Sure I can. So spanning tree, VLAN 150, and if I execute the help feature, I see the option priority. So I can say priority, and the default priority is 32768 plus 150, which is 32918. So I just need to set it to a number lower than this, and I believe 100 will do. So let's try and set it to 100. And it does not allow me to set the priority to 100. Now, remember that number I asked you to remember on the VLAN ID field, when the priority field has been broken into 4-bit priority and 12-bit VLAN ID? That first bit value for the VLAN ID part was 4096 now, wasn't it? Hence, because just those 4 bits were designated as a VLAN ID, you can only make changes to the priority field in increments of 4096. So bridge priority must be in increments of 4096, which is why I put the bit values on the board to make sure you understood this part. So can I make the priority 0? Sure I can. And now, if I say do show span, short for spanning tree, VLAN 150, switch 1 says that it is the root bridge. And that concludes for now the spanning tree lab.